All right, welcome back. Now that we have got a box class in place, let's go ahead and get one drawn. And then after we see the box, then let's see if we can get some collisions in place so that we can have our ball colliding with it.
All right, let's go over to the game class now and go back to that create demo actors method, and let's spawn a box into our demo scene. So what I'll do is I'll make a box variable, which I'll call box, and we'll set that equal to an instance of box. Now, of course, box's constructor is going to take in a width and a height, so I'm going to give a width and height of 32 by 32, and this will match the graphic that we're using for the box. All right, now that we've got the box spawned, let's set its position. We'll tell our box that its position is going to be at a new vector of 100 by 100. So, now if we run the game, we see
have a box. We do.
We do indeed have a box, but we don't have collisions. As you can see, the ball went directly through the box, no collisions.
Oh, right under it. Let's adjust the velocity just a little bit. I just want to see it.
Push it down a little bit?
Yeah.
Let's do 2 by 2. And then
perfect.
Straight through the middle.
Couldn't have asked for any better than that.
Do this 1, 2 by.
You didn't like that?
5.
Picky.
There we go.
You're just looking for a more interesting angle because now it's time to get some collisions in place. So let's build up on this. Let's start out simple and make it a little bit more sophisticated. Let's first go ahead and get it so that we register a collision by maybe changing the color of the box to red or something.
Right, just do the basic collision detecting between the ball and the box.
Okay.
And to do that, let's go over to the ball class now, and then scroll down to the bottom where we have the checkbox collision method, and let's start putting together an implementation for it. The first part is going to be a loop that goes through all actors and looks for boxes. So we'll make a reverse for loop using the actor list, so actor.actors .count to drive the loop. And inside of this loop, we're going to first make a box variable and attempt to cast the current actor as a box. So make a box variable and set that equal to actor.actors sub I casted as a box. And then if that box variable is equal to null after we attempt the cast, then whatever actor we were looking at was not a box, and we don't need to check collision on it. So instead, we'll just continue on to the next iteration of the loop. Now, if we got this far, now we are looking at a box, and we need to check that box and see if it's colliding with ourselves as a ball.
Okay.
So we'll do an if check, and we'll use our bounds, this dot bounds, because as of XNA refresh 1.0 refresh, the rectangle type has an intersects method, which can be used to check and see if two different rectangles are intersecting.
Good old Microsoft, making things simpler and simpler.
Yeah, very easy in this case. So we've got this dot bounds, and if we look at some of its methods, we have an intersects method, which is going to return whether or not we are intersecting with another rectangle. And that other rectangle in this case is going to be the box's bounds. So we can drop in box.bounds and
we got
finish
one
off
more
parenthesis.
Alrighty.
Now, if these two rectangles are intersecting, the ball and the box, then we're going to consider this a collision. Now, since we don't have the necessary code to calculate a new velocity based on this collision, we're instead just going to take the box we collided with and set its color to red. And this will let us test and see if our collision check is working. So we'll take that box, set its color to red. So now we should be able to build and to run. As the ball hits the box, it will turn red, indicating that we did in fact have a collision with that box.
Let's let it stay up for just a second. Okay, so the next thing we're going to need to do is go ahead and get some code into place so that we can actually collide with and bounce off of it. And in order to do this, we've got to take some things into account, don't we?
Right. What we need to find now that we can tell that we've collided with the box, but that doesn't give us enough information to tell how we should bounce off of it. Depending on whether we hit the top, right, left, or bottom of the box, we will go in different directions. If we hit the top of the box, we go in a different direction than if we hit the left of the box. So we need to be able to see what side of the box that we're currently on.
Okay. All right, let's go ahead and close that down. And now let's turn our attention over to the box.
What we're going to do in the box class is we're going to first set up a new field. This field is going to be an array of floats that are going to act as, you could say, corner angle markers. It'll be a way where we can divide, like if you drew an imaginary circle around the center of the box, it's the way that we're going to divide that imaginary circle into different pieces.
So basically we can take each of the corners so that each of the straightaways could exist in this imaginary arc of the circle. So you could say that the circle's been divided up into 4 arcs.
Right, just imagine that you cut the box into 4 pieces by drawing a line through each corner.
Yeah.
And then watch how the sides, each side is directly between each of those new corner lines.
Exactly. And then with that, we can use some special trickery, some special math to come up with some information that will let us figure out what side the ball has collided with.
All right, so to put this field in, this is going to be a public float array field that I'm going to call corner markers. And we're going to initialize this array inside of the box's constructor, right after we set up width and height. So we'll first take a look at corner markers, not color, but rather corner markers, and set that equal to a new float array with size of 4. Then we're going to set the first element, and since we're going to do this collision in a more simplistic, or this bounce code, in a more simplistic method first. We're going to set it up so that it will work for square objects.
Right, which of course this will later have to be changed because in the end we're going to be dealing with rectangular shaped boxes for battle blocks.
Right, but for the moment, if we look at a square, we can divide up this imaginary circle equally, and each of those points will represent a corner.
So you guys are going to see 2 ways of going about this.
But this, you can consider this the simple way. So what we need to do is establish that first marker, because once we know where the first one is, we can keep adding to that the same amount to get an equal spacing all the way around the circle. So we'll look at the first corner marker, so corner marker is sub-0, and we'll set that equal to mathhelper.pi divided by 4. Using mathhelper since that will return pi in a float, and we're doing divide by 4 since we need to get the first marker. If we were to start at 0, we need to move a certain amount to find that first, you could say 45-degree angle through one of the corners, and that would be pi divided by 4. Once we have that initial point, we can use a for loop to get the rest of them, because we can just add on for the remaining 3. So I'll drop down a for loop to go through the rest of the corner markers. So that's corner markers.length, and I need to change I starting at 1, because we've already set up 0, now we need 1 through 3. Or excuse me, 1 through 4. 3 if you look at the elements 0-based. 4th element is 3, so all that fun stuff. But what we need to do here now...
So let's make sure this is right. So you've got 2 more that you're wanting to take into account right now?
3 more. So
3
we
more,
want...
because we've got 0. So I is going to start out at 1, and then you're going to go 2, but counter markers holds a
4.
Length of 4. So as long
0,
as it's less than...
1, so that's 1, 2, and 3 that we're looking for.
All right.
That's the elements that we're trying to get now.
Okay.
Just so we're completely clear on that.
That's right.
All right.
That was great.
Almost had me second guessing myself there. But
I was just making sure it was nice and clear to everyone.
Okay, yeah.
I wasn't trying to make you second guess.
It was weird, but
a lot of people are used. Here's the deal. A lot of people are used to seeing this with dot length -1, but this is a little different this time around because of how we're working with this.
True. But if we have count -1 or length -1, instead I want to actually go.
Score 1 for me today, yes. Okay, I'll be quiet now because I'm really having fun with Logan. Okay.
Well, it's actually the reverse loop that we use the -1 because we're going less than not.
Exactly.
1 minus.
Okay.
But all right. So now that we have found this number, whatever it may be, we're going to use that number to find. We're going to apply that to the current corner marker. So if we took corner marker sub I and set that equal to the last or the previous corner marker, that would be corner marker sub I minus 1. And so we find what was the last thing we found, and now let's add on to that some more. We'll add mathhelper.pi divided by 2.
Right.
So that way we get another quarter of the circle around.
Mm-hmm.
And with that will initialize our corner marker. So we will have 4 equidistant corner markers all the way around the square.
Exactly. Okay, so with that in place, now what we need to do is turn our attention back over to ball.
Yep, we need to go into ball. Now that we have the markers to mark out the square, now we need to find which range we fall into if we look at ourselves as the ball. I'm going to build before we leave the box class, and then we'll switch over to the ball class.
Okay, so back into the whole checkbox collision method. And from in here where we've got, it's setting the color of the box red, we can go ahead and take that out. So now what we need to do is put some code in there that will basically allow us to figure out what side of the box we were on, and we're going to use we're going to come up with this information through radians. And that's what's going to allow us to know basically where on the circle we were at. If you want to imagine that circle being around the box, in the end, it's what angle did we get returned, and that's
right.
what we're
As a
able
matter
to
of
use.
fact, that those angle markers are in radians currently
That's
because
right.
we were using pi to derive all of them. So now what we need to do is we need to find where the ball is. If we took the ball and imagine that it's somewhere around the center point being the box, if you drew a line between the box to the ball, what angle would that line have?
Right.
So what we're going to do is first get a unit vector from the ball to the box. So we'll do like a vector2 variable that I'm going to call direction. We'll set that equal to vector2.normalize. And now we have the position of the ball. So if we're feeding this information over, we could just use the position by itself, but that would only work if the ball was centered around the origin, 0, 0.
Right.
Instead, we want to get this angle based on the position of the box, as though the box were the origin.
Was 0, 0, right.
So in order to do that, we need to take the ball's location, or in this case, this dot position, and subtract the box's position. And then we essentially have adjusted coordinates now in direction, pretending that the box was the origin. Now what we can do is find the angle that normalized vector, that unit vector
If you were to draw
would have.
this out, we have a triangle now.
Right, we now have...
From the center of the box, draw a line that goes up to wherever our ball happens to be. Now draw a line straight through your box and call that X. And you've got a triangle if you finish off the sides. But here we go. We can now use ATAN2 to go ahead and give us some information that we can use.
Right, based on that angle, we can use ATAN2. It'll look at the signs of X and Y and figure out what quadrant it should be and do the necessary corrections so that no matter where it is in a full 360-degree radius around the box, we get a correct angle back.
That's right.
So what I'm going to do to store this angle is define a float variable called angle, and that angle will be equal to floatcast result of math.atan2. We'll feed in the directions y component and the directions x component. Now that alone is ATAN2 returns a result in a range of negative pi to positive pi, and I want to make sure that we only cross a threshold from a high number back to 0, because if you imagine going up all the way around the circle, if you start at 0 and then 360 degrees later you have 2 pi, you're going to cross the threshold back over. The problem is if we leave it negative pi to positive pi, then we essentially have the top half being one sign, the bottom half being the opposite, and we cross that threshold twice, which would make checking the collision or checking the range very difficult. So to make it easier, we'll add pi to the angle. So mathhelper.pi, and what this will do is give us a range of 0 to 2 pi instead of negative pi to positive pi. Alright, now that we have this angle determined, we can use that and find where this falls within our corner markers, because our corner markers also measure an angle, but if you look at the area between them, you can look at that as a range of possible angles.
That's right.
We need to find what range we fall within. So let's start an if statement where we take a look at that angle, and first we're going to do a check and see if we have hit the top side of the box. And that would mean, are we between corner marker 0 and corner marker 1? So if the angle is greater than or equal to the box's corner markers, sub 0, and less than the box's corner markers, sub 1. If that is the case, then we have just hit the top of the box. And that would be angle is less than. I completely managed to miss that whole variable. Alright, so if we've hit the top of the box, we need to look at the ball's velocity y and make sure that it's negative, since negative y will cause the ball to travel upwards, and if we hit the top of the box, we want the ball to begin traveling up. So what we'll do is we'll take the ball's velocity y and set that to minus math.absolute for the velocity y. So this velocity y. And the reason we're using absolute here is we don't want to have to worry about sprite ejection, meaning a case where after the collision the ball is so far into the box that moving in its new direction doesn't take it outside the box. Because if we used a wall-style collision where we simply reverse the direction, we could end up in a scenario where the ball sits there and vibrates inside the box. This way it'll make sure that if it takes more than one tick for it to get free from the box, it will continue moving in the same direction until it is free. So that takes care of the top of the box. Now we need to check the next range, which is going to represent the right side of the box. So what I could do is I could copy the if statement, drop that in below, and change it to an else if. And now what we're looking for is to see if the angle is between markers 1 and 2.
Okay.
And we'll block that in. If we're between markers 1 and 2, that means we've hit the right side of the box, and that means we need to make sure that the velocity x is positive for the ball. And to save a little bit of time here, I could copy the same line since very little changes. We want to look at velocity x, make sure that it is positive of whatever value is currently in velocity x. And now we can copy that entire else if block, paste it in, only this time we're looking for the range between corner markers 2 and 3. And if we're in between markers 2 and 3, we've hit the bottom of the box, and that means we need to look at velocity y and make sure that it is positive, or traveling in a downwards direction. Then one last check, and this one I'm going to do as a final else to the entire statement, and that is if we have not hit the top, the right, or the bottom of the box, then we must have hit the left side. And the reason I'm using this as an else instead of checking a range between the two values is it's between markers 3 and 0 on the left side of the box that we have that crossover point. We'll have, if you look at like if you were to imagine the x coming out of the origin of the box, as soon as we cross that threshold and go into, we'll go from 2 pi to 0, so we'll flip over, and that would make checking a range very difficult.
Exactly. This is where you've basically taken the fact that we crossed over twice, and by adding pi above, knocked it down to where we're only crossing over one time. And this is that area where you're going to cross over one time.
This is in fact where we're crossing over from.
Right. And so there's no reason to check anyways. I mean, come on, let's just think about this logically. You've already checked the top, the right, the bottom. What's left? We've only got one side left anyway, so I mean, it might as well say
from
else.
that point, just from an optimization standpoint, we've already determined that we're not on any of the others. So we're
because
on the
if you did an
side.
else if and this failed too, then was there really a collision to begin with? You know?
Exactly.
Okay.
So the final check is we've hit the left side of the box, and that means we need to set the velocity x to be negative velocity x. So we'll drop in velocity x and make sure that that is always traveling in the negative direction in this case.
Okay.
And that has all of the new velocity code in place, so we should be able to build in text. Yeah. So watching left side bounce, very good. And how long is it going to take now to get all the way back around to the box? Too long. I'll change the velocity here so that we go from 2 to 1.5. That way we should hit the top of the box now.
Very nice.
And there we go. So we have a left side check working, a top side check working, and with enough time we'd be able to check the remaining sides, but just to speed this process, same side pretty much. To speed this process, since I do want to check the right side and the bottom side bounces as well, let's go back to the game class, and we happen to be in now, and let's change the box spawning code to spawn a grid of boxes instead of just one.
Sounds good.
So let me drop down below this first box, and let's first make two variables to describe the grid. I'll make two integers, one called numCalls, I'll set that to 8, and another integer called numRows, and set that to 6. And we'll use this to make a grid of that size, 8 by 6. So we'll use this using two nested for loops. Let's make the first for loop for x and make that continue across the length of, the amount in numCalls. We'll make another loop for y that uses numRows. And then inside here is where we want to spawn boxes. So I'll simply cut the existing box spawning code, paste that in, and now we'll change the position. So we want x to be whatever value in x is, times 80 for spacing, and then plus 48 for an offset off the edge of the wall.
Bunch of random numbers, but again, proof of concept.
But again, this is just, the reason these numbers exist is these are just numbers that I like the look of that made it helpful for testing. And we'll do the exact same thing for y. We'll set y, spacing of 80, and an offset of 48.
And this should give us a flood of boxes that we can now watch a ball bounce all around the place.
So let's take a look. Now we have many boxes, and we can test the rest of the collision. So there we have some off the left, one off the right side.
Yeah, they've already gone, all of them.
So, and yeah, that's top, and yep, that's all of them.
Very nice. Looks good. Awesome.
So that has the collision working. And with that,
I think that's pretty much everything we set out to accomplish in this particular video.
Right, and that is to get collision and bounce set up and working.
It was too much fun. Okay, with that, that is going to wrap up this video. We'll be back with you in just a second. Thanks a lot.